All right, in this video, I'm going to go over polynomials. This is another thing we're kind of reviewing before we get into college algebra. And before we get into the multiple term polynomials, we need to focus on the parts of a term. And that is probably the most important term I'm going to be using here is the word term. All three of these things are called a term. The collection of all of them. The coefficient, the number out front, being multiplied by the variable. And the variable has an exponent. Now, the exponent represents the degree. That's how you know what the degree of the term is. So the coefficient of the term, the variable of the term, and the exponent or degree of the term. You need to know all that vocabulary before we can move on. Because we're going to be dealing with a lot of multiple term expressions. Hence the word polynomial. Poly means more than one. Nomial means numbers, I think. Sound looks like numbers. Anyway, you might get something like this. This is a binomial. Before we were just looking at one term. That was a monomial. Mono means one. This is a binomial. Two. So there are two terms. So we have this term right here, the negative 15, and the second term here, 7x. Now, coefficient of the first term is 7. Variable is x. What's the degree? Well, the degree is 1 because it's x to the first power. There's an understood 1 there. What about this term? Negative 15. Coefficient is 15. What's the degree? Well, it's not 1 because there's no x there. It's actually 0. There's kind of an understood x to the 0 there. Now, why would it be, x to the 0? Because anything, any number raised to the 0 power is 1. Remember that? So, but the degree of the entire polynomial itself is 1. Now, they call this 7x here, they call it the leading term. The leading term because it has the highest degree of x. So you just look for whichever variable has the highest exponent, and there's your leading term. They usually write it on the leftmost term. Sometimes you might find it somewhere else. You can always rewrite it on the left. So since this is our leading term, they have a special name for the coefficient. It's called the leading coefficient. All right. Now, they might give you a problem like this, where they say identify the degree, the leading term, and the leading coefficient of the trinomial. This is a trinomial. There's 3. 3 terms in a trinomial. So, this is probably the easiest math you're ever going to do. Just find the highest power of the variable. The variable in question is p. Write that term first, because it's being raised to the third power. And the second highest power next, and the lowest power, and so on. What is the leading term? 2p cubed. That was easy. Leading coefficient, 2. There you go. Degree. Let me just... leading coefficient. Degree equals 3. Exponents 3, degrees 3. Wow, that was easy. Now, let's do some actual simplifying, some math. Plus 6x minus 2. 4x squared minus 6x squared. 6x squared. Well, I'm running out of room. Minus x plus 7. There we go. Just enough room. So, you're taking one polynomial and you're subtracting the other polynomial, right? I would do adding first, but I want to be more efficient and just say that subtracting is just adding the opposite. If we were adding, we can just write all this out without the parentheses. Okay. Well, let's just go ahead and add them first, since I just did all that. How do we simplify it? We combine like terms. And I wrote something wrong here. That is supposed to be 4x cubed. I was wondering what was going wrong there. All right. 4x cubed. We combine like terms. You cannot add these two together. That's why they're a 4-term polynomial, you know. That we cannot combine those two numbers, but we can combine terms that have the same degree of x. And all you do is you keep that same degree of x, you just combine those coefficients. That's what makes it so simple, sort of. So let me get a different color marker here. So we have x cubed, right? And there's another x cubed. Okay, we have an x squared. Use a little different kind of underline for that. And we have another x squared there. Okay, and we have just an x and just an x, a little squiggly. And then the constants are left. No need to underline those. So, now that we've identified all of our like terms, we can combine them. First of all, the x cubed, negative 7 plus 4. Negative 3, right? Negative 7 minus 6, negative 13, x squared. the variable the same. 6x minus x, positive 5x, negative 2 plus 7 is plus 5. And there you go. Boom, there's your answer. Now that's adding them. If we were subtracting them, things would be much different. I'm going to leave that answer there so we can compare the answers. Because when you're subtracting, you've got to understand something. This negative 1 there needs to be accounted for. It changes everything about this polynomial. Nothing about this one. This one is all the same. Negative 7x cubed minus 7x squared plus 6x minus 2. But this one, now you have to use the distributive property. This distributive property takes that number and it multiplies it by every single term in that polynomial. So it's kind of easy. It's just a negative 1 being multiplied by all of them. So when you multiply something by negative, you multiply a positive by a negative, it gives you a negative, right? If you multiply a negative by a negative, it gives you a positive. So you could say that you're just changing the sign of every single term. So if this is positive, now it's negative. Now that's positive. That's positive. And now that's negative because you just multiplied all of them by negative 1. Okay. Now combine the terms again. X cubed, x squared, x, and the 7s. Negative 7 minus 4, negative 11x cubed, negative 7 plus 6, negative x cubed, or squared, sorry. 6 plus 1x, 6x plus 1x, 7x. Negative 2 minus 7 is minus 9. Boom. Completely different. So you got to make sure that you use that distributive property there. Completely different answer from when you're adding it. See that? Also, when you're combining like terms, if you feel the need to cross things off as you go, you can cross them off, combine the x squared, combine the x. I find that helpful. So I know that I've accounted for every single term that I'm combining. All right. Now, we kind of already just did this, but I make sure that we completely understand this part. We just went over adding and subtracting, so let's go over multiplying. Multiplying polynomials. Now we're just taking one term and we're distributing it to 3 other terms. Just like that. You have to multiply this by every term individually, not just the first term. 3x times 7x. 3 times 7 is 21. X times x squared is what? When you multiply 2 variables together, you're adding their exponents, right? So it's x cubed. 3x times 2. 2 times 3 is 6. X times 1 is just x. 3x times negative x. 3 times negative 1, negative 3. X times x squared, because it's 1 plus 1, right? That's 2. Now, you need to write it in order. Some teachers are going to be finicky about those sort of things. And there's your answer. Going to be doing a lot of distributing in college algebra. All right. Here we go. This is probably the most important thing. 9x plus 3 times 2x minus 7. Let's try that. What if you get a binomial times a binomial? Well, then that thing happens called FOIL. First, outside, inside, last. But if you just remember, think about it for a minute. If you just remember the distributive property where you multiply each term in one polynomial by all the other terms in the other polynomial, then you can multiply any polynomial by any other polynomial. This is just something they use for binomial times a binomial. But there are going to be other times where it's not always going to be two binomials, you know, it's not always that easy. But if you have trouble remembering that, just remember that you take in this first term and multiplying it by the first term in the other binomial, hence the first term of each binomial. Multiplying those. Okay, so check that. Outside. So these are the inside terms, these are the outside terms. So we're multiplying those two terms as well. Okay, inside. These are the inside terms, multiply those two together, and the last term. Last two terms. This is the last term in the first binomial, and this is the last term in the second binomial, multiplying those together. But also, you can tell we're just multiplying this term by both of these terms and this term by both of these terms, because that's just how the distributive property works. Multiplying each term by each term. All right, so 9x times 2x. 9 times 2, 18. X times x is x squared. Okay, 9x times negative 7. 9 times negative 7. Negative 63, I believe. X times 1 is just x. Okay, now we're doing the inside. 3 times 2x plus 6x. 3 times negative 7 is negative 21. Okay, we're done. No, we're not. Something going on here. There's an x and there's an x. Got to combine those. Always combine like terms. You're not done yet. This stays the same. Negative 63 plus 6. 63 minus 6 is 57, huh? Larger number, still negative. There's your answer. All right. Forgot to check that one off. Okay, so now that we've done a binomial times another binomial, and we've learned about FOIL, now it's trying to crank it up a notch. Let's try a binomial 3x minus 5 times a trinomial x squared plus 5x plus 8x squared plus 5x plus 8. Woohoo! All right. It's not that bad. You just take each term, take one term at a time. Multiply it by each term in the other one. I like to draw those little hills. If that helps you, you can draw little arrows as well. Oh, and the other one now. Cover that up. Boom. So, it's 3x times x squared. 3x, this is a 1. 1 plus 2 is 3, so 3x cubed, or to the third power. We prefer to say cubed, most of us. 3x plus 5x. 3 times 5 is 15, right? X times x, x squared. 3x times 8. 3 times 8, 24. X, don't forget that x. Now, negative 5 times x squared. Negative 5x squared. Negative 5 times positive 5x. Not a positive. Negative 25x. And then negative 5 times 8, negative 40. Okay, now we combine like terms again. X cubed. There are no other x cubed. Okay. X squared. And there's an x squared. We can just... What about x? Yeah, we got 2 x's there. And that's it. Okay, so 15 minus 5 is 10 x squared. If you're thinking, whoa, wait a minute. I thought we were adding those exponents together. No. That's when we're multiplying terms together. But when you're adding terms together, exponent stays the same. (24 minus 25), negative 1, right? The 1 is understood. You hardly ever write ones when they're in certain places in math. If that was a 1, we'd write it a 1. But since this 1 is a coefficient, then it's understood. Same as that 1 in the exponent, understood 1. And that's it. Wow, that wasn't so bad. 2 steps, boom. Just like multiplying a binomial times a binomial. Okay. Not done yet. What if you got something like this? What the? Well, I thought we were talking about multiplying polynomials, and we were. Now we got to get into, well, what comes after multiplication and division? Exponents. I'm not going over division of polynomials today. That will be in possibly much later math course. Anyhow, what do we do here? Well, what is an exponent? It's just taking whatever you've got and multiplying it by itself, right? So this is something that people struggle with because we need to know the difference between 4x squared, 4x quantity squared, and 4x minus 1 squared. 4x squared, that is just a term. Coefficient of 4, variable x, and it's squared. 4x quantity squared, that is much different. We're taking 4x and we're multiplying it by another 4x. Well, that was a weird looking 4. Right? 4 times 4 is 16. X times x is x squared. Completely different number from that, right? Now, 4x minus 1, you don't just... Now, if you were thinking, oh, here, I could just do this, 4 squared times x squared, and you would actually be right. But this does not work like that at all. You're taking that quantity and you're multiplying it by itself. So it's quantity 4x minus 1 times 4x minus 1. Do not think that you're just squaring this piece and squaring that piece, because there's a little bit in the middle that you would be missing. All right. So now we have two binomials like we just did just a few minutes ago. 4x times 4x, first, outside, inside, last, FOIL. That's easy. 4x times 4x, 16x squared. 4x times negative 1, minus 4x. Negative 1 times 4x, minus 4x. Negative 1 times negative 1, positive 1. Combine like terms. And there you go. All done. Now, if you had just squared the first part and squared the second part, you would have this negative 8x in the middle here. And you would have been marked wrong. I doubt you'd even get, partial credit for that. And there's a shortcut that people use for this. They say that all these binomials that you're squaring have a certain format to them. It's always an x plus a constant number. X number plus a constant number. And so they use a shortcut. They just say, well, if that is squared, then that's going to be x squared plus 2ax plus a squared. And you're like, what did you just say? That's just a formula. That's a formula they use to take a shortcut. They could just be like, okay, well, this whole thing squared is 16x squared, right? Okay, we got that. Now, 2ax, we take this, multiply it by this, so we have 4x times negative 1, so we get negative 4, and we multiply that by 2, and we get negative 8x. Boom. And then we take this last part, that a, and we square that as well. Negative 1 squared. Negative 1 times negative 1 is 1. There it is right there. See, that's just a shortcut people use. You just got to remember to multiply that middle term by 2 and multiply them together. Multiply by 2 and you get that negative 8x. Or you could just remember your distributive property and know that every term has to be multiplied together. All right. Last one. This one is called difference of squares. What the? This is just what we just did, right? Not quite. The signs are changed for that constant over there. First term is the same. Well, let's just FOIL it and see what happens. First, outside, inside, last. 2x times 2x, 4x squared. 2x times negative 7, negative 14x. 7 times 2x, positive 14x. 7 times negative 7 would be just negative 49. Combine like terms. Negative 14 plus 14, well, that would be 0x, right? And the x is being multiplied by 0, so anything multiplied by 0 is just 0. So these just kind of canceled each other out, right? Boom. And you're just left with that and that. So they have a shortcut for this too. They just say to multiply these two terms together and multiply those two terms together. But I'd rather FOIL everything out just to make sure I got it right, you know. These two binomials, they're called conjugates of each other. It's just the only difference is that sign. That's what a conjugate is. And they use that for certain things. Later on, you'll learn. And you've got to know that before you start college algebra class. All right, well, that's it.